All right, we got 10 o'clock here. Thank you everyone for joining. My name is Sean Davenport Smith. Hopefully everyone's keeping warm today. Today we've got David Gardner, Regional Sales Manager of PVI. And we're going to be talking about PVI's new Centurion water heater. And with that, I'll turn it over to Dave.
All right, thanks, Sean. Welcome everyone on our lovely 10-degree morning, it looks like here. But I'm actually very excited, and I know Sean and everyone at Long's very excited too to kind of be the first introduction and announcement of our new water heater. It's the Centurion 2000, and just diving straight into this bad boy, which this thing is just amazing here. Like I said, we're all very excited about it, but the Centurion is a 2 million BTU PVI water heater. It's made from a lot of the similar technologies that you guys have seen with PVI throughout the years, the heat exchangers and Aquaplex material. We've added some new features to it with a high turn down air fuel delivery system. And as far as I know, this is the first domestic water heater in the industry that comes standard with O2 trim technology. Just kind of going over quick the overview of the unit itself. It's a vertical fire tube design. The heat exchanger, just like the Conquest, is our Aquaplex. This is up to 99% efficiency, very low pressure drop, small footprint. This 2 million BTU water heater is designed to fit through your standard door. And one of the new features that we have is our feed-forward control temperature system, that this unit can control the discharge water temperature plus or minus 4 degrees, which is the same as your master mixing valve. And when I talked about earlier, so it's a high turn down unit, it has a 20-to-1 turn down. So it's a 2 million BTU input, and that means it can turn all the way down to 100,000 BTUs. That's pretty much what you're using for a residential domestic heating load in your house. I'll come back to the O2 technology here in a second, but just our standard warranty out of the gate, we have pretty much the same warranty as the Conquest, 15-year warranty with a labor and parts warranty. And then we have the addition to kind of up that warranty to a full 15-year non-prorated and 2-year parts and labor warranty. The heat exchanger itself, if anyone's familiar with the Power VTX, this is a very similar design where it's a vertical fire tube. The tubes are a little bit smaller and we have more of them in there, but the heat exchanger itself is our Aquaplex material. It goes through the same pickle and passivation process that I believe everyone's familiar with. And we have our dual inlet for that dedicated building research return line. Looking at the back of the unit here, I'm going to try to get the laser working, is right on the bottom. It's a counterflow design, so cold water is coming in on the bottom. It's going to work its way up through the top of the heat exchanger and out at set point. And right here is your recirc return connection. It's kind of hard to see these dimensions, but it's designed to fit through a door. When we look at the back of the unit, there's a circulator here on the back, and this is what we use for our feed forward sensor. This pump turns on intermittently, but what the unit's doing is it's looking at the temperature at the top of the heat exchanger and the bottom of the heat exchanger, and it's using that to calculate flow. When the top and the bottom of the heat exchanger are the same temperature, we know there's no flow. As we start seeing the temperature drop at the bottom, that's our way of seeing that, hey, cold water is being introduced into the system, or we're also looking at the return water temperature from the recirc line. From there, we can actually modulate, and with that 20-to-1 turn down, we can just pretty much dial in exactly what firing rate we need to maintain temperature, and that gives us that extremely tight plus or minus 4 degree set point on our discharge temperature. When we look at the combustion system, just following the pipe here, this is our gas supply coming into our SSOV, which is the safety shutoff valve. That's going to connect to the air fuel valve. On the air side, we have a K&N air filter, same one that everyone uses on their trucks. You pick up at Advanced Automotive Parts store, and the air and fuel is going to mix inside of the air fuel valve, go into our blower, which is the pre-mixed combustion gas, and then go into the burner. The air fuel valve, this is a new technology to PVI, but this is what allows us to have that 20-to-1 turn down and maintain a proper combustion level throughout the entire turn down range. One of the problems you have with the blower is once you start slowing it down, you get to the point to where the blower is turning, but you're just not moving any air, and that's about 6-to-1 turn down ratio. With this air fuel valve is right here on the air side, there's the shutter that's going to open and close, and on the same shaft, there's a little plate here, and that's a custom cut orifice that as that valve opens, it's going to allow in the appropriate amount of gas to maintain that 10-to-1 air fuel ratio that ramps up and ramps down. We could do 20-to-1 turn down just with this valve and having the blower on off. That's not very efficient from an electrical standpoint. So the blower ramps up and down with this valve opening and closing, and it's going to maintain the O2 levels right where they need to be to make sure we have a good solid flame and we don't have excessive O2 levels, which I'll talk about here in a second. In addition to that load matching, we could have varying flow rates up and down, and this unit's not going to short cycle because it could load match exactly what's happening out in the system. The controller itself is extremely powerful. It can have up to 16 units communicate itself. We don't need a standalone controller on the wall. Everything can network through this single controller. One thing I really like to highlight is straight out of the box, you don't need a proto node. You can connect to it with backend MSTP, IP, Modbus, all the standard protocols. It's extremely simple to where you land your wires on the terminal strip, go into the controller and say, here's what protocol I want. It identifies that, it will find the server. You can confirm the MAC and IP address of that server. In addition, it has a security protocol built into it that all you have to do is enable it, and it will only accept commands from that server, that MAC and IP address. So if someone has concerns about someone hacking into the BMS system and changing set points or disabling the equipment, if it doesn't recognize that server, it won't accept any command prompts from it. There's a USB connection on the side. This is what we use for doing firmware updates, software updates. But a really nice feature is here at altitude, it's a lot more work involved to do combustion calibration. And where we could go, say we have a site that's got 4 units there, we get the first unit set up, we get the combustion settings in there, from the get-go, since these are coming up from sea level. But once we have that first unit calibrated, we can actually take that information, combustion settings, and clone it over to the rest of the water heater plant and be able to do the fine tuning on the individual units. But like I talked about in some of my other trainings, when you take something from sea level to Colorado, it doesn't necessarily even light the first try. So once we've gone through kind of the work to get the first unit going, we can now expedite the process of getting everything set up and ready to go for the startup. So hopefully reducing some time. The other key feature I really want to talk about this is the easy setup. This is taking advantage of the O2 trim system in the unit. So let's say there's a job site, we need to do temporary startup on there. Temperature's dropping, they need hot water, something happened, and we need to bring these units, turn them on maybe a week, 2 weeks before the startup's actually scheduled. This will allow us to do a temporary startup using the O2 sensor. So if we can make sure there's flow on the system, the unit's going to come on, it's going to go 100% fire rate. It's going to go through and actually trim itself, set its combustion where it needs to go, and then go down to 80%, trim itself, so on, so on, so on. So it will do its own temporary startup just to get us through a little tight period there where we need to, be able to have domestic hot water. For the O2 itself, it's very something I think that's typically overlooked, that you have problems if you don't have too little O2. It's an indicator that maybe we're not burning all the gas in the system. There could be unburnt gas going out there, increased emissions. If you have too much O2 during the process of combustion, it actually affects your efficiency. And if we take kind of our standard, I believe everyone's very familiar with your efficiency curves. But what happens with those increased levels of O2, you actually change the dew point of the natural gas. So instead of condensing at that 135, give or take point, and that's where you always see the the spike there in the efficiency curve, if our O2 levels start increasing to 9%, 15%, this is where the dew point starts to kind of level out to where you could have return water coming back at, say, let's say we're at 15% O2, return water temperature at 90 degrees, we're not condensing. We're operating at about 88, 87% efficient at best, just because the O2 is out of whack. This is something that, this is one of the reasons a lot of manufacturers stress to make sure you go through and do the yearly maintenance and tuning of the equipment, because if your combustion gets completely out of whack, you can run into issues where the unit might not light, to where your efficiencies nose drop, and it's just going to start to really impact how that system works. The way the O2 itself works is we have an O2 sensor mounted right on top of the burner. It's in the combustion chamber, and it's looking at real-time O2 levels. Even when we do startup on the equipment, we have a test port that's kind of downstream. This is actually looking at what's happening inside the combustion chamber. The controller itself, we can control that blower down to a single RPM. And that's how we trim the system, is we already have what we know is the correct air-fuel ratio. If we can tweak the blower just by a couple RPMs, that's going to allow us, up or down, to make sure we have that perfect air-fuel ratio that we need to maintain. About that, it depends on the firing rate, but that, I believe it's 5% to about 7% O2 to make sure that we're burning all the natural gas and we're operating in a safe condition. In addition, going back to the efficiency curves, we're going to make sure we're utilizing as much of that heat exchanger as possible to condense and get all that energy that we're putting into the unit. When we start looking at the units themselves, is we have a water heater management. So when I mentioned that we're going to have up to 16 units talking to each other, we can have up to 16 units that communicate with each other, and the units themselves have the ability to sequence. So just on these couple units we have right here, it's kind of hard to see in this picture, but there's valves that we have on the outlet of the unit. In this scenario, our default logic always has one valve open, so we don't accidentally deadhead a recirc pump. And let's say that there's a load on the system and it starts to increase and only this unit hears fire. Once it hits about 50%, it's going to go, hey, my load's increasing. I'm a water heater. I need to react and make sure I give hot water now when people want it and need it. It's going to send a signal over to the next unit. It's going to fire, bring itself up to temperature, then open that valve before any water goes out into the system. And the reason we do that is we want to eliminate any cold water or hot water sandwich effect that would happen if we just opened this valve and ran water through the unit before it's had a chance to fire and come up to set point. We don't want to see these temperature fluctuations. And then from there, we'll go all the way up doing that for 16 units. And it'll operate almost like a boiler plant, to where they'll all ramp up, ramp down together, kind of stage on, stage off. And once the firing rate gets down to about 25%, we have a little time delay there to help prevent with the short cycling, and just hopefully eliminate that factor and cycle that unit off and stage all the way down. And if you get to about 100,000 BTUs, that's probably about what you might see on a recirc loss, maybe up to 200,000, based on the size of the building. The footprint itself is extremely small. These units can actually do zero clearance. We need to have a 24 inches in between pairs of units to make sure we can go through and perform all the PM service and be able to access any components for anything that could happen for maintenance in the future, repair, replacement. But it's going to drastically reduce the footprint for that water heating system you need in a building. For the venting, I'll just touch on that real quick, is we can do common venting on these. We will need to go through and do a draft calc, but we have the ability to common vent without a draft system. And the last thing I want to throw out here real quick is we also have the ability to pair these with a storage tank. This would be for a system that has a dump load. So I always think like hotels. If there's on-site laundry, you're going to need a hotel because they're going to have that dump load. If there's a hotel that that does their laundry offsite, we can just line these water heaters up. That's just a quick example, but we have the ability to size these for whatever's appropriate for that system. So I know it's a lot of information that we just threw at you, but I wanted to thank everyone for the time real quick, and I'll turn it back over to Sean.
Thanks, David. Yeah, we're real excited about the Centurion. The O2 trim is very important, especially for our climate. You know, if we're out there starting up the water heater today, it's 10 degrees outside. Come summertime, you know, all of our building owners are definitely going out there and getting techs to recalibrate their machines. But with this unit, it's going to work like a charm all year round. So I really appreciate that, David. Everyone, please join us next week when Andrew Smith will be talking about Amerion, the evolution in VRV technologies. Thank you, everyone. Have a great day.